One of the ways we can have IPv6 addresses configured on clients is through a dynamic method known as stateless auto configuration, or SLAAC for short. I really like that name, by the way, SLAAC. And what is happening with SLAAC is clients are listening for router advertisement messages. Well, who do you think sends a router advertisement? It's the router. So a router, first of all, needs to be running IPv6 unicast routing. In addition to that, it has to have an IPv6 address assigned to that interface. So a global IPv6 unicast address, in this case, is 2001:1:A/64. So those are the two requirements. There is a third requirement as well. And that third requirement is that the prefix has to be a /64. It has to be. So those are three things you need to look out for while troubleshooting SLAAC. Number one, IPv6 unicast routing needs to be enabled. Number two, there has to be a global IPv6 unicast address on the interface. And number three, oh yes, that address has to be a /64. Some other issues you'll have to look out for is things like router advertisement messages. You see, since SLAAC is depending on those router advertisements, if for some reason you have suppressed router advertisements, which they are enabled by default, but if you've suppressed them, then SLAAC won't work either because those router advertisements are not being sent. So if we look at our topology here, we have PC1, who is enabled for IPv6. So PC1, if we analyzed right now the output of PC1's running, not running config, but IP configuration, we can see that it does not have an IPv6 address at all. Well, pardon me, it has the link local address. As soon as you enable the TCP IP stack for v6, so if we go to the properties here, we'll see we have TCP for IPv6 enabled. Our clients are going to generate their own link local address for IPv6 communication on the local link. But we need that global address. And in this case, we want to have it automatically generated via those the prefixes advertised in the router advertisements. Windows 7 clients, Windows 8 clients are enabled for this by default. You don't have to do anything special at all. They are waiting for those router advertisements. They want to use them to automatically generate their IPv6 addresses. So as long as we can successfully reach DSW1, then DSW1 should be able to give us the prefix that we need. But I want to go over to the DSW1 and verify if the requirements that are needed in order to send that prefix to the client are set here. Let me show you that. So on DSW1, first of all, we said that we're going to be relying on router advertisements. So let's see if router advertisements are even being sent. Let's double check that. So we'll type in debug IPv6 neighbor discovery. Router advertisements are part of the neighbor discovery process, which rely on ICMP. So with that in mind, let's also look at the interface we're going to be dealing with here. That interface is interface VLAN 10. So show IP interface, or IPv6, pardon me, interface VLAN 10. And if we scroll down to the bottom, I don't see any indication that router advertisements have been suppressed. But I want you to notice here that we've received no debug message output at all from router advertisements being sent. In order for router advertisements to be sent, the router has to be enabled for IPv6 unicast routing. So show run pipe to include IPv6 unicast, and we get 0 results returned. So let's go ahead and enable IPv6 unicast routing. And once we do so, right there, you can already see router advertisements being sent. Let me shut off that debug. All right, stop. All right. So we can already see we sent out a router advertisement out on VLAN 10, and there's the prefix we are advertising. So notice the prefix was 2001:DBA:/63 on link, auto configure, out it goes. Let's go back to PC1. See what's happening over there. On PC1, ipconfig, and PC1 still has not generated its own IPv6 address. You see, it's looking for that prefix, which it is receiving. It is. It is. Want to prove it? Yeah, let's look at Wireshark. Let's go to Wireshark. And we're going to debug ICMP in this case. V6. All right. What are we looking for? We're looking for a router advertisement to come. Patient, patient. There it is. There it is. Scroll back down. Where did it go? All right, let's stop the capture. There we go. Router advertisement right there. IPv6 from the source. We crack it open. See what information we can find inside of it. There we go. There's the prefix. So we are receiving it. We can see that. We are receiving it. But we're not using it to auto-configure our address. We're not. Why not? Because of the other rule we stated. The prefix being advertised must be a /64. In this case, it's a /63. That's our issue. That's the issue right there. So let's go back to DSW1. And now let's type in on DSW1, configure terminal interface VLAN 10, and let's change that. So let's remove our IPv6 address. All right, what is that IPv6 address? Do, show, run, interface VLAN 10. There it is right there. So let's take that, let's remove it, and let's add in the correct one, which is going to be a /64. That's what we want, a /64. And once we do that, the next advertisement that goes out to our client, they're automatically going to get it and configure their address now. Look at that, already done. There's the IPv6 address using the prefix of 2001:DB8 /64 and then using EUI64 to generate the lower 64 bits of their IP address. And notice this right here. That is the default gateway. It's a link local address, FE80. Whose link local address is that? It is the link local address of the device that sent the router advertisement. That's who it is. So the client will automatically take that address and use it as the default gateway because it's using the router advertisement from that device. So therefore, it's its default gateway.